For an excruciating 80-day period, London teetered on the brink of collapse under the relentless V1-inch buzzbomb attacks. Unbeknownst to the public, their salvation came from a diminutive American invention that German physicists had previously dismissed as scientifically unfeasible. This is the tale of that remarkable weapon, the American VT Fuze, and how a compact device, no larger than a human hand, systematically dismantled Hitler's reign of terror and saved London from utter devastation. Remarkably, the Germans never saw it coming. Our narrative begins just 1 week after the D-Day landings, on June 13, 1944, as Allied soldiers fought their way through the Normandy hedgerows. At 4:15 in the morning, Hitler unleashed his promised vengeance weapon, the V1. The first one struck a railway bridge in London, killing 6, injuring 30, and leaving 200 homeless. This devastating attack signaled a new phase of the war for the German High Command. The V1 was a source of immense pride, being the world's first cruise missile and a technological triumph years in the making. Carrying nearly a ton of high explosives and flying at 400 miles per hour, the German leadership believed this weapon would finally. The German military leadership recognized the immense potential of their advanced weapons program to undermine the British people's resolve. Major General Walter Dornberger, the head of this initiative, had conducted extensive calculations. Even if only a quarter of the missiles reached their targets, they would deliver more explosive force to London than the entire Blitz of 1940 and 1941. Remarkably, this could be achieved at a tiny fraction of the cost required for manned bomber operations, with no risk to German pilots. The scientists at the Peenemünde Army Research Center had ample reason to feel confident. They were the brilliant minds behind the world's most cutting-edge rocket and jet technologies. Dr. Robert Lusser, the designer of the V1 missile, had. The V1 flying bomb's incredible speed and high-altitude trajectory made it an immense challenge for Allied pilots to intercept. Calculations showed the odds of a successful interception were statistically improbable. Pilots had to push their aircraft to the limit, diving down on the target and getting within a mere 200 yards. Close enough to be destroyed by the explosion if their daring maneuver succeeded. Despite the daunting odds, some British pilots managed to pull off this perilous feat. Equally crucial were the anti-aircraft guns lining the British coastline, which played a vital role in the defense against these deadly missile attacks. German ballistics experts had calculated the odds of a direct hit on such a small, fast-moving target to be less than 1 in 10,000. Contemplating this statistic, they anticipated that only 1 shell out of every 10,000 fired would successfully strike its mark. This was not mere propaganda, but the harsh realities of warfare. At the time, conventional anti-aircraft shells relied on time fuse mechanisms. The gun crews had to visually acquire the target, while their newly developed radar systems determined its speed, altitude, and trajectory. Then, they had to manually set a tiny timer on the shell itself, all in the hopes of intercepting the elusive target. The V1 flying bomb posed a formidable challenge for the British defenders. Launched from the continent, these unmanned aerial vehicles had to be precisely intercepted and destroyed in a matter of seconds to prevent catastrophic impacts. The Germans, who had developed the same technology, were confident in the V1's invincibility. For a time, the initial V1 onslaught struck terror in the hearts of Londoners, their distinctive pulsating roar heralding the arrival of these devastating weapons. Gunners had a mere 30 seconds to detect, track, and destroy each V1 before it reached its target. A split-second error in timing or a slight miscalculation in speed could result in the shell exploding harmlessly in the air. The British, however, were determined to neutralize this threat, drawing on their own expertise in the same technology. Over the course of the V1 campaign, the defenders gradually honed their tactics and improved their accuracy, gradually diminishing the impact of these attacks. While the initial V1 assault was indeed terrifying for the people of London, the city's resilience and the skill of its defenders ultimately prevailed. The ominous sound of the buzz bomb struck fear in the hearts of those on the ground, as its sudden silence signaled the final plunge of the deadly projectile, leaving them with mere seconds to pray for their safety. Meanwhile, in France, German intelligence received increasingly unsettling reports. The British were adapting to this threat with remarkable speed, with the interception rate climbing from around 24% in the first week to over 60% by the end of June. This exceeded their initial predictions, but their scientists reasoned that it was indeed possible, speculating that the British may have had superior radar technology or more disciplined personnel. The German forces observed a perplexing phenomenon in early July. Their V-1 flying bombs, which had been soaring steadily, suddenly erupted into flames without any direct anti-aircraft hits. The shells were exploding in close proximity to the missiles, sometimes up to 100 feet away, yet the V-1s were plummeting from the sky as if struck by a powerful force. Simultaneously, British gun crews were reporting an improbably low number of rounds fired per V-1 downed. This unexpected turn of events left military analysts puzzled, as the data defied conventional explanations. The German military leadership faced a perplexing situation. Oberst Max Wachtel, the commander of the V-1 offensive, was alarmed by the sudden and unexpected success of British gunners in shooting down the V-1 flying bombs. Wachtel suspected sabotage at the launch sites or a potential flaw in the missiles themselves. He ordered immediate inspections, diagnostic tests, and even conducted test firings over German-held territory. However, the results consistently showed the V-1s performing flawlessly. The problem, it seemed, only occurred when the missiles were flying over the English Channel and directly into the British defences. Perplexed by this phenomenon, the German leadership was compelled to confront the unexpected effectiveness of the British anti-aircraft measures. The V-1 offensive, which had been designed to overwhelm the enemy, was now facing unexpected challenges that threatened its success. The Allies' enigmatic new weapon, the transformative VT Fuze 634, a deeply unsettling possibility loomed. 637 The Allies had developed 638, a revolutionary new weapon, 642, but without a single piece of captured evidence. 645 Its true nature remained a mystery. The secret American Fuze 647, what they confronted 649, was a technological breakthrough. 650 not born in a single stroke of brilliance, 652, but from years of persistent American innovation. 657 It was known as the VT Fuze or variable time fuse. 703 a deliberately misleading name meant to suggest 706. It was merely an improved version 707 of the old clockwork timers. 710 The reality was far more radical. 712 It was a proximity fuse, a miniature marvel of electronics. 717 that contained its own tiny. The artillery shell concealed a compact radio transmitter and receiver within its nose. 726 When the shell passed near a target, such as the metal fuselage of a V-1 bomb, the transmitter emitted a continuous radio wave. 733 The receiver detected the echo of these waves bouncing back. 738 In an electrical switch called a thyrotron instantly triggered the detonator. 741 In essence, the shell could sense when it was close enough to inflict damage. 749 Requiring only a near miss rather than a direct hit to be deadly. 754 This revolutionary technology upended the traditional dynamics of anti-aircraft warfare. 802 The gunners faced a daunting challenge, hitting a tiny, fast-moving target at 400 miles per hour. However, the proximity fuse made their task much easier. While German engineers had explored over 30 different proximity fuse designs during the war, they had all fallen short, deeming the technical obstacles insurmountable. Constructing a complete radio system, transmitter, receiver, antenna, and power source, compact enough to fit inside a shell's tip was the first hurdle. But the real challenge lay in hitting the general vicinity was all that was required, as the fuse would handle the rest. This concept, which German engineers had previously considered and dismissed as impossible, proved to be a game-changer. The technical hurdles they had faced seemed too immense to overcome, from building a miniaturized radio system to the 1940s saw the development of delicate vacuum tubes and glass batteries that needed to withstand immense forces to be used in military applications. German physicists initially scoffed at the idea, likening it to building a grandfather clock out of fine crystal and then firing it from a cannon. However, by the summer of 1944, American factories, driven by the wartime spirit of the nation, were producing 40,000 of these resilient devices every month. The components had to be engineered to survive being fired from a cannon, enduring forces up to 20,000 times the force of gravity and spin rates exceeding 25,000 revolutions per minute. This was a daunting challenge, akin to constructing a precision timepiece from fragile materials and then subjecting it to such extreme conditions. Despite the skepticism of German scientists, American industry rose to the occasion. Factories, fueled by the determination of a country at war, churned out 40,000 of these specialized units each month by the summer of 1944, a remarkable feat of engineering and manufacturing prowess. The tale of these remarkable devices and their daily production is a testament to the American approach to warfare. It's not just about battlefield triumphs, but also victories in the laboratory and on the assembly line. The Johns Hopkins Applied Physics Laboratory, led by the brilliant scientist Dr. Merle Tuve, was entrusted with this project. Tuve assembled a team of the nation's sharpest minds from universities and corporations, orchestrating a massive collaborative effort, a hallmark of American ingenuity during times of crisis. Their mission? To solve the issue of the fragile vacuum tubes. They sought assistance from a company that would play a pivotal role in this endeavor. The engineers at Sylvania Electric faced a daunting challenge when tasked with designing the intricate components for the proximity fuse. Their tiny, delicate hearing aid parts needed to be reinforced to withstand the immense G-forces encountered during firing. Through ingenious engineering, they encased the components in specialized wax and plastic to protect them. To power the device, they developed an ingenious glass battery that remained inert until the moment of firing. The shock of the shell leaving the gun barrel would shatter the glass vial, instantly mixing the electrolyte and bringing the battery to life. Every aspect of this technological marvel was a small triumph of engineering. However, this achievement was not solely about scientific brilliance. It also represented a remarkable victory of American industrial might. The proximity fuse's development exemplified the nation's ability to rapidly mobilize its factories and manufacturing capabilities to meet the demands of wartime. The sheer scale of the American industrial mobilization during the war was staggering, dwarfing even the most ambitious efforts of the German Reich. The production of the critical VT Fuze, a key component in many Allied weapons, was dispersed across over 110 different factories, each specializing in a specific part of the manufacturing process. This compartmentalized approach meant that most workers were unaware of the ultimate purpose of their labor, with one facility producing the batteries, another the vacuum tubes, and yet another the plastic casings. Companies that had previously focused on consumer goods like refrigerators and radios completely retooled their assembly lines to support the war effort. At the peak of Crosley Corporation's wartime production, their workforce numbered over 10,000 employees. Countless individuals, many of them women, had joined the workforce to support their loved ones overseas during the war. These dedicated workers were manufacturing an astounding 16,000 proximity fuses per day. While this crucial detail is often overlooked in historical accounts, the stories of the home front are just as significant as the battles themselves. The numerical data paints a remarkable picture of two nations engaged in a colossal struggle. While Germany resorted to forced labor from concentration camps to construct its V-1 weapons, American workers voluntarily put in overtime, driven by a profound sense of patriotism. By the war's end, the United States had produced an astonishing 22 million proximity fuses. The American industrial might proved instrumental in thwarting the German V-1-inch wonder weapon during the war. Factories in the United States produced more of the high-tech fuses for these missiles than the total number launched by Germany throughout the entire conflict, at a staggering cost of over $1 billion in 1940s currency in a single month. By the end of August 1944, the British had completely reorganized their defenses, moving the majority of their anti-aircraft guns to the coastline to form what they dubbed the diver belt. This strategic maneuver was brilliant for two key reasons. Firstly, it created a concentrated barrier of firepower against the V-1 attacks. Secondly, it allowed the British to take full advantage of the new American technological advancements that had proven so effective in countering the German wonder weapon. The coastal gun belt along the French shore was a formidable line of defense against the V-1 flying bombs. Every V-1 had to pass through a specific altitude range, ensuring that any duds would fall harmlessly into the sea rather than reach their targets. This proximity fuse technology was a closely guarded secret, shielded from German hands. On a pivotal day in late August, a squadron of V-1s roared across the French coastline, their engines pounding as they neared England. These flying bombs were detected by American-made -584 Seychelles rupees radar systems, a vast improvement over earlier radar technology. The new system automatically tracked the targets, calculating their speed and trajectory, and relaying that critical data. The anti-aircraft guns were programmed to automatically aim and fire at the approaching V-1 flying bombs. 1412 The gun crews only had to load the specialized shells. 1416 These shells were tipped with the VT 1420 proximity fuse, transforming the sky into a deadly trap. 1425 As the V-1s entered the kill zone, 1427 the guns unleashed a barrage. 1429 The shells streaked upwards, 1432 requiring far fewer hits to destroy the targets. 1435 The proximity fuses detected the flying bombs, 1441 and in brilliant flashes, 1447 Hitler's vengeance weapons 1449 were swiftly neutralized. The German V-1 flying bombs, once considered an unstoppable wonder weapon, were now facing a devastating setback. On a single day, 82% of the incoming missiles were destroyed, a level of effectiveness that just weeks prior would have been deemed impossible. This catastrophic interception rate triggered crisis meetings at the highest levels of the German command. Wachtel, the German commander, was convinced that sabotage must be the cause. How else could their vaunted weapon be failing so spectacularly? Yet, the frantic search for traitors and faulty parts turned up nothing. The only conclusion left was the one their own scientists had deemed impossible. The Allies had perfected the proximity fuse, a technological breakthrough that allowed them to shoot down the V-1s with unprecedented accuracy. The Allies spared no effort in their attempts to counter the V-1 threat. They launched the V-1 missiles at various altitudes, from treetop level to high in the stratosphere. Massive waves of these weapons were sent over, in a bid to overwhelm the defenses. The Allies also tried launching them at night and in poor weather conditions, but none of these tactics proved effective. The kill rate remained alarmingly high, as the invisible shield continued to hold firm. The proximity fuse program was a remarkable achievement of the war, with not a single intact fuse falling into German hands throughout the entire V-1 campaign. Ironically, during the Battle of the Bulge, German troops managed to capture an entire American ammunition depot filled with these advanced proximity fuses. Crates of artillery shells equipped with VT fuses had been in the Allies' possession since 1622. However, their own experts had dismissed the possibility of such a device, 1628, so they never even considered examining the captured munitions. 1631 Unaware that they held the key to their greatest mystery, 1636 The Allies remained blinded by scientific arrogance. 1639 As a result, the V-1 offensive, 1643 intended to bring Britain to its knees, was effectively over by September 1944. 1645 Of the more than 9,500 V-1 rockets 1650 launched at Great Britain 1652 from the ground, only about 2,500 reached London. 1654 While these attacks tragically claimed over 6,000 civilian lives, 1701 the V-1 offensive ultimately failed to achieve its objective. 1703 The number of casualties inflicted by the German V-1-inch flying bombs was a mere fraction of what had been intended. General Frederick Pyle, the head of Britain's anti-aircraft command, later estimated that without the proximity fuse, the casualties would have been at least 4 times higher. This little electronic device had saved tens of thousands of lives and may well have saved London itself from devastation. After Germany's surrender, Allied officers interrogated the men who had run the V-1 program. Their ignorance of the British countermeasures was complete, as Colonel Wachtel admitted. The German forces suspected the British had better radar, but they never imagined the existence of a shell that could think for itself. When German scientists were finally shown the proximity fuse, their astonishment was profound. The American scientists were astonished when they examined the captured VT Fuze. They marveled at how the vacuum tubes had survived the launch and the batteries continued to function. Inspecting the sophisticated circuitry, they reluctantly acknowledged that American technology was at least a decade ahead of their own. Dr. Tuve, the project leader, attributed their success to a collaborative spirit of democratic cooperation, where scientists, engineers, and factory workers all worked in unison, a stark contrast to the rigid, top-down structure of the German war effort. The proximity fuse's remarkable performance had a profound impact. The outcome of the war was being decided just as much in laboratories and on assembly lines as on the battlefields of Europe. While Germany poured its resources into revolutionary wonder weapons, America focused on multiplicative technologies, clever innovations that exponentially enhanced the effectiveness of existing weapons. The VT Fuze, for instance, did not replace the anti-aircraft gun but made each one 5 to 10 times deadlier. This change was dramatic. Before the fuse, it took an average of 2,500 heavy artillery shells to shoot down a single V-1, but with the fuse, that number dropped to a mere fraction. The Allied forces' development of the proximity fuse during World War II marked a pivotal moment in the conflict. This revolutionary technology, kept secret until 1945, proved to be a game-changer on the battlefield. Surpassing even the atomic bomb in its effectiveness, the proximity fuse allowed for a level of precision and lethality that the German military could scarcely comprehend. The mass production of this superior idea, rather than sheer bravery, secured a decisive victory for the Allies. The official announcement from the War Department hailed it as one of the most important weapons developed during the war. For the German scientists, who had been baffled by their failures, this revelation was a moment of shocking clarity. They had not been outfought, but rather outthought and outproduced. The declassification of the proximity fuse's secrets in August 1945, shortly after the war's end, shed light on a technological triumph that had tipped the scales in favor of the Allies. This innovative weapon, with its unparalleled effectiveness, had played a crucial role in the Allied victory, showcasing the power of strategic thinking and industrial might. The Axis powers had staked their hopes on a select few meticulously crafted weapons, while the United States had mass-produced millions of serviceable life-saving devices. Sharing this remarkable chapter of history helps ensure it is never forgotten. The proximity fuse's legacy lives on in the technology powering modern air defense radar and countless other electronic systems. Yet its most significant legacy was etched in the skies over London in 1944, when 82% of Hitler's terror weapons plummeted harmlessly into the sea, signaling a profound shift in the nature of warfare. The triumph of a novel armament signified a win for the quiet, collaborative brilliance of a liberated populace. If you're interested in exploring other covert weapons from the Second World War, we have an episode highlighting the remarkable tale of the P-51 Mustang available. Appreciate you tuning in.